Problem 3 should be pretty short because pretty much essentially all we're really doing here is just using the concepts that we just looked at in problems 1 and 2 and just applying them to a story problem. So in this particular story problem, they're just using Kepler's third law of orbital motion. And according to Mr. Kepler there, kind of a smart dude, he stated that you can approximate the period P in Earth years it takes a planet to complete. Let me get this out of the way. One orbit of the Sun using the function P equals d raised to the 3/2 power, where d is the distance in astronomical units, also known as AUs, from the planet to the Sun. So find the approximate length in Earth years of a Venusian year. Not Venetian. I think those are blinds. Venetians are blinds, I think. Venusian. That sounds weird. All right. Sounds like a Matt Damon movie, but that's a Martian, isn't it? If Venus is 0.72 astronomical units from the Sun. All right. So here's what we know. Let's write down the only thing that we really know here. We need to work this formula. They're giving us a formula here that allows us to find how long it takes in Earth years for Venus to orbit around the Sun. All we really know here, literally, is that the d, the distance in astronomical units for Venus, would be 0.72 astronomical units from the Sun. So here's what we're going to do with that info. Item number 1. Let's first do this with it. Okay, let's use that formula. And so now if we know that d is 0.72, it makes sense to me to just simply plug that in there for d. And that will give us how long it takes to get around the Earth, or the approximate length in Earth years of how long a Venus year would be. Okay, so now from here, quite literally, ladies and gentlemen, from here I would really just use your calculator. So here's a screenshot of the calculator. Me taking 0.72, raising it to the 3/2 power. If you're in a rush or you don't like fractions, do you realize that 1.5 would have worked right there? Right where that 3/2 would have been. So you can just take 0.72 and raise it to 1.5. And so what is that actually trying to tell us right there? What is it telling us? It is telling us that Venus year is approximately 0.61 Earth years. Okay, so you'll get a problem like this. I'm pretty sure I assigned a story problem. It might involve a radical, it might involve a rational exponent, but the key to working the problem is just understanding what information is given to you and how to use that information appropriately to get to the correct answer. Let's move on to 4.